last time we talked about compound interest and just how to figure it, like if you put so much money away just once and just let it sit there or what you'd get after so many years. These are more realistic questions. Like when people want to do this, when they want to invest a big lump sum, their main questions are, yo dude, how much do I have to put in? You know, it's like, how much money do I need to invest to get what I want? Or the second question that we'll go today is, how long will it take for me to get this money to where I want it to be? So these first three questions, we'll kind of do them the long way, and then maybe we'll come up with a short formula for it, but you got to do it the long way first. They say, you know, you're going to need 200 grand for your child's education in 18 years. Here's what's different about last time. That's our final amount. That's what we want to have. We want to have 200,000 bucks, right? Does that kind of make sense? And parents especially do that when they have a newborn kid. They're like, hey, 18 years from now, you kind of see the math behind that. They're going to go to college, right? You know, so how much do I need to put away now into an account? Well, they go into an account that's giving you 4% interest earned quarterly. How much do we need now? Let's start. Do you remember the formula? Is this guy right here. 200,000 is A. We know that. That's what we want. What we don't know is our principal, so that's going to be P. And everything else we got putting in. 4%, changing it to a decimal, would be 0.04. When they say quarterly, how many times a year is that going to be? 4. And for those who weren't here last time, all this stuff is on the other side of the paper. There was a typo right there. That should be a 4 for quarterly. To the 4 times how long? 18 years power. Let's do this in 2 moves, man. Move 1, figure out what 4 times 18 is for me real quick. 4 times 18, 72. Cool, so I'm going to strike that guy out and do 72. And here's the craziness. Like, I'll make this real simple. If you had 200,000 equals P times, like, just say, like, P times 100, what would you do to solve for P? There's a times 100 hanging out. What would you do to solve for P? Wouldn't you divide both sides by 100, right? That's exactly what we got going on here, but all of this is just times P. So our move is to divide. We're going to do 200,000 divided by all of that. And that's going to equal P in this case. I just want to get P all by itself. They want to know how much do I need. So I'm going to write it down and then divide. And to punch it in, it's just like we did last time, using parentheses very wisely. So I'm going to do 200,000. Make sure you get the right amount of zeros. Please punch with me if you got a calculator. 200,000 divided by, you must use a parenthesis to start with. 1 plus 0.04 divided by 4. Close that parenthesis up, raised to the 72nd power. Are you guys okay with that? And you should get a number that's less than 200,000 back, because that's what we want as the final. So it's usually going to be really, really nasty. We'll round it to 2 decimal places since it's money. So that's either 21 cents or 22 cents. 21 cents or 22. What do you want? 22. So 97,699, and it was 22. Is that what it was? Cool. That's how much money you would need. I like to keep it real with you, though. This is what the financial planner would say. You know, if you would like, 200,000 bucks in 18 years, you need to put away 97,622 cents. The person who's investing would not put that money away, most likely. Like, I'm going to do 97,699 cents. They would probably do like 98,000. Or 100,000 or something, you know what I'm saying? They'd round it to make it a little more sense, but that's the bare minimum you would need to get $200,000 back. Why? Why did it suck so much? What about it made it like not that great? The time, which was 18 years, or the interest rate of 4%? What's the weaker thing out of those two? The interest rate was less than 4%. So you had to put a big chunk of it away, is my moral. You needed to put basically 100 grand away to have children. It's kind of because that sucked. Let's do this again. Yolanda wants $15,000, so what she wants is like the final amount. So we'll start with that, $15,000. What we need to know is how much she's going to invest. So when we say how much money will she invest, that's the principal, times 1 plus 0.0625 over, there should be a word like monthly or quarterly or something like that in there. You see it is monthly. So what number do you want to put downstairs? 12. And then we say, like, she just wants to have that in 5 years because she wanted to put a down payment on the house. So we want to do 5 times 12 up there. We're going to compound it monthly. There's the 12. And she's going to do it for 5 years. So we're going to put those together first. 5 times 12 is 50. And what we use to solve for 2? Divide by that big old number. So I could care less if you write it down or not. I want you to write that down. Like that's, I think, very, very handy. But now it's just going to be 15,000 divided by those parentheses. 1 plus 0.0625 divided by 12 raised to the 60th power. Just like that. She needs $15,000 for a down payment increase. How much does she have to invest there? Over to two decimal places, so 14 cents, 14 cents, 14 cents, $10,983.14. All right, let's try it again. How much should be invested now? So that's how we know we're using this little scenario in an account that compounds semi-annually with a rate of 7% to get back $20,000 in 10 years. $20,000 is our final amount. How much invested now is the principal. Our interest rate is 7%, which that is awesome, right? You know, that's really, really awesome. When we say semi-annually, we can check the chart. It's on the other side of the paper for when you're quizzing, you know. The chart is 2 times a year. And then how many years had it been? 10. 10 is an okay amount of years. 7% is awesome. So let me clean that up to be 20, and go ahead and push that in. 20,000 divided by all that right there. So I did 20,000 divided by 1 plus 0.7 divided by 2 in parentheses, raised to the 20th. And I got $10,051.32. $10,051.32. That to me sucks, because if you want 20 grand, you're basically putting up half of it right there. You know, that's like 10,000 of it is like half of that. What sucked about it? The period. The period is very long time. The longer the investor is to yourself an okay to good interest rate and have a beefy amount of time. Are you with me? If the time is the thing that's really going to make you money in that case. So if we're planning for 50 years in the future, we're probably going to ask you to put up a very small rate. So what I'm going to do is first make up a scenario that you will never ever see in your life, but just to emphasize it. How much should be invested now in an awesome account that compounds annually with a rate of 21%? Can you see that that is ridiculously amazing? Like 5% is good. 21%, you ain't getting it, right? You ain't getting that. I want to get $500,000, right? I would love to get $500,000 back. And how much time am I going to let this work? A huge amount of time of 40 years. Let's pause. Take a guess. How much money have you got to put into an account that you're going to let sit there for 40 years and you get 21% interest? Talk to your neighbor. Just take a guess. What do you think? So we're going to do 500,000 equals our principal times 1 plus. The rate is 21%. We got in a little bit of trouble last time with the decimals on that. It's not going to be 0.021. It's just going to be 0.21. So it's going to be 0.21 divided by how many times we get. Ooh, weird. How many times we get an interest when it says annually? just once. So you can put it over 1 if you wanted to. You literally don't have to do that because 0.21 over 1 is still 0.21. And then raised to the 40 times 1 power, which is still 40. Yeah, boy. Let's divide that out. 500,000 divided by 1 plus 0.21 to the 40th. How much money do you need to put up to get $500,000 back? $244.09. I have a real question you don't have to answer. Could you scrounge that up before the school year's over with? Could you scrounge up $250? Do you know what I'm saying? This is where I was talking about about using graduation money to invest. What really did it? This. You ain't getting 21% interest. Are you with me on that? But you can have this if you start when you're 18. Do you know what I mean? You can have 40 years really, really, really fast if you let it sit till you retire. You know what I'm saying? It is very, very possible. So $244.09, or was it 10 cents? 9 cents, right? And 9 cents. That's awesome, dude. Investing. How do you feel about that part of the lesson? Just this divided by this. Cool. The next one's going to get a little messier, right? It's going to be a little messier. So we're going to do 2 of them. I know there's 3 on here. We're going to do 2 of them, and then I'm going to make up a new formula. So we can just use the formula for that, right? So check it out. They say find the time required. That's what people really want to know. How long will it take for me to get this much money? Find the time required for an investment of $4,200 to grow to $6,100. Let's talk right there. Which one is the money we're paying? The 42 or the 6,100? 42 we got comfortable. 61 is the money we want to get back. Interest rate of 6.2% compounded monthly, rounded 2 decimal places. So we need to start with the money that we're getting back of 6,100. We do need to write all this down. This is a messy one, guys. The principal is 4,200. We're still using the same old formula, right? So 1 plus our rate, so we got to change that to a decimal of 0.062. Since they say monthly, we'll divide it by 12. And I'm going to do a little trick here. I need to realize it's n times t. N is 12 and t is time. We don't know the time, so don't write this yet. It's like 12 times t, but don't write that down because I'm going to twist it. Is 12 times t and t times 12 the same thing? Yes or no? Let's switch this weird one to be t12. You'll see why in a minute. T times 12. We have to solve this for t, and this is serious math. T is up in the exponent. So that's where we did that last chapter with the logarithm. You know, we logged both sides, but our first move is we have to get rid of this first. That is a times 4,200, so we will divide both sides by 4,200. 6,100 divided by 4,200. Most of the time it's not going to come out nice, so I don't even want to change that to a decimal. What you can do if you want is cancel out those zeros and use 61 over 42. I could care less if that fraction reduces because it's going to come out weird and decimally anyway, right? So just leave it like 61 over 42. And that's 1 plus all this mess that we had before, which I thought we did really good with that last chapter. But here's why we wanted to get that base all by itself, is because to get that exponent to come down, we're going to log both sides. So it will be the log of, in parentheses, 61 over 42 equals, when you log both sides, the exponent comes down in front. So T12 times log of all the stuff in the parentheses. What a mess. But I know that's a really weird move. You're like, I don't quite understand why that works. That's what you learned in Algebra 2 class. You know, we're not taking that. I just want you to trust me. Logging both sides makes that exponent come down in front of the log. Cool? And now we're in the same scenario as before. All of this stuff, you don't care what's in the parentheses. I'm just going to black that out. Please don't black it out. I'm just going to black it out. You don't care what's inside of there. Isn't all this crap being multiplied together? I would like to get this t all by itself. So to get rid of all this, we are going to divide both sides by all of that. We'll just write it down on the first one, so when you look back you can see, but it's going to be the log of 61 over 42 divided by the 12 is there, and the log of the parentheses is there. Yeah, it's a mess, man. That is a mess. That is a mess, dude. That is a mess. And it's not as easy as you think to type that in. So I want us to type it in together so we don't hit the wrong buttons. It's all about the parentheses. And what really matters is the denominator. So we'll grab our calculator and we'll type the numerator first, log, and remember I'll have that calculator for you on your homework if you didn't have one right here with you, log of 61 divided by 42. And I'm closing up the parentheses. Do you see that is the top, what I have in black? Cool? And then the fraction bar is divide by, right? And here's what makes it work. You must start with a parenthesis now. You've got to use a parenthesis. So parenthesis, if you see the denominator is 12, then the log button. And what makes it hard is log buttons automatically start a new parenthesis up, right? So in the log, that's that 1 plus 0.062 divided by 12. That was in the log parenthesis. You need to close him, so you close that parenthesis, and then you got to close the one that we started. So it's like at the end, double parenthesis closing. We'll do a few of them, right? So hit it out, boom. That's what they say. How long should it take for this to happen? It's going to be nasty decimally. They want us to go to 2 decimal places all the time. So what do you think? 6.03 or 6.04? 6.03, right? So that's the time it will take in years. For us to turn $4,200 into $6,100 will take a little over 6 years. In my honest opinion, we should have rounded to the nearest year, but homework wants us to go to 2 decimal places, so we'll do 2 decimal places. But you know that the time, sorry I had bad handwriting there, the time should have taken a little over 6 years. Holy typing nightmare. Let's get better by doing another one of those. Find the time required. When do we do all this logging stuff? When we're looking for time. Find the time required for an investment of $8,600 to turn to 20 grand. So 20 grand is the final number, and 8,600 is what we invested. Interest rate of 5.4%, so 1 plus 0.054, compounded quarterly, so 2 to the 4. And then we need to do 4 times t, but this is the time where we're going to backwards and put T4 instead of 4t. This is the weird part. We don't know t. He's up in the exponent, so that's why logs help us. Can't do any logging until this 8,600 is out of the way. So here's where I'm going to set up my new formula. After this one, I'm going to give you a different formula. Would you believe the first move we've done both times is to divide by that number right here, yes? So it'll be 20,000 divided by 8,600. And if you want to cancel out those zeros, you can. So just move it like 200 over 86. And that'll be 1 plus 0.054 over 4 to the t4th power. The move now to get the exponent to come down is the logs, right? So we're going to log both sides. So it'll be the log of 200 over 86 equaling, exponent comes down in front, so t4 log of parentheses. Ugh, what a mathy math. This is probably the most challenging math thing we'll do all semester long, right here, this one thing. To get t all by itself, don't we need to divide by 4 log of the parentheses on both sides? So I will have the log of 200 over 86 divided by 4 logs of the parentheses, bless you, equaling time. What a mess. When you type it in, here's the magic. These unknown red parentheses need to be there. Right, those unknown red parentheses need to be there. So let's type it together and see if we get the same number. I'll always help you type it in if you have it written down for me. It's like, this is what I want to type in. I just don't know how to type it in, right? So log of 200 divided by 86. Close your parenthesis up. Anytime you hit a log button, it's going to start a parenthesis. Divided by, where's the magic starting parenthesis to do the denominator? Start it up, 4 log, and then put that new parenthesis, 1 plus 0.054 divided by 4. Close that parenthesis up, close the magic parenthesis up. Hit enter, and see if you get this. That didn't look right. I hit the... Did you get that number instead? Sorry, I had to type in I fixed my typo. We got about 15.73. Here's the good news. If you did not like that, I am on your side. That is a lot of work to do that, so I will invent a new formula for us to follow for this to work, so we don't have to write all of that stuff down. Okay? But I want to show you where it came from first. So here we go. You know there's not any room to the right. You don't have a problem over here. Down to the right, let's write this formula. I'll come back to this if needed. We will do this. It's a big one. It's log of A over P. Let's stop real quick. How do you feel about P being the principal and A being that final amount? Are you with me on that? Divided by big magic parenthesis, N is the number of times compounded, right? So sometimes it's quarterly, sometimes it's monthly. You know, we put a 4 there, we put a 12 there, or whatnot. Log of 1 plus R over N. Close that parenthesis up, close the big green parenthesis. That will equal your time. And A, P, R, and N are the same numbers that we've been using before, but if you look back, you'll see that that's what this is. This is the original amount that we wanted to have at the end. This was the principal. We cut some zeros off of it. I could care less if you cut the zeros off of it or not. And then this is the quarterly, and then here's our rate over 4. So let's try this formula. Let me snip it out on the last one. When do you use it? When they ask you to solve for how much time it takes in an exponential situation. So last one, let's see if we can use this cool formula just from the get-go. It says find the time required, that's the only time you get to use this formula, for an investment of $3,000 to double. Ooh, double tricky. They didn't tell you how much it's supposed to be, but $3,000 is what we started with. How much would it be if it doubled? $6,000. So A, if you want to write this down, you can. A is 6,000, because that's the amount we want to have when we're all done, and the principal is 3,000. How do you feel about knowing who the rate is? Are we down with knowing who the rate is? It's 7.1%, but we got to change it to a decimal, right? And then it says semi-annually. What does semi-annually mean? How many times a year would that be? Twice. So I'm going to use this new funny formula. I'm going to do the log of A, 6,000, over P, 3,000. I can care less if you cancel those zeros out or not, because the calculator is just going to make it a decimal anyway, right? So I'd say don't even worry about reducing it. You know, just leave it 6,000 over 3,000, right? Divided by big parenthesis, N, need your help with that. N is number of times compounded. What would that be in this case? 2. Log of 1 plus the rate, got to change it to a decimal like we always have, 0.071, divided by N again, which is 2. Then close your big parenthesis up. To me, this class is designed to see where the formula kind of came from and then make a new formula. That's all you got to do. So could we punch that in and see how what we get? Not an easy thing to punch in either. Not an easy thing to punch in. So log of, I'll do the big number, 6,000 divided by 3,000, close that up, divided by parenthesis 2 log, and then it started my new parenthesis for me, so I don't have to hit it, 1 plus 0.071 divided by 2, close that log parenthesis, close the big parenthesis up. And I like us to try to do a little bit of common sense to realize, okay, we're trying to double our amount. It's pretty good interest rate, so the better the interest rate, the less time it should take in that case. It shouldn't take a million years, you know what I'm saying? It should not take 100 years. Maybe not thinking about 88 years, I was like, oh, that number's right, I need a typo. Right, so did you get pretty darn close to 10 years in this case, right? That's the reason. It's like, alright, to double the range, it takes about 10 years. We'll do 9.93 years, because we said down to 2 decimal places. Okay? We're going to help you type this in if you need help typing it in. Let's do some homework.